In this example, we're going to be first verifying that this function satisfies the hypotheses of Rolle's theorem. And then if it does, then we will be finding the numbers C that actually satisfy the conclusion of Rolle's theorem. Now, if it doesn't actually work, so if our verification process shows that it does not actually do it, then we would just say, no, it does not do it. You don't do anything past that. All right, so since this is an example, try to work it out on your own first. So pause this and then resume it so you can see the actual process that we go through to do it. All right, so there are three requirements because we're talking about Rolle's theorem here. The first and second requirements are exactly the same as they are for mean value theorem, and that is that we need to verify that it's continuous and differentiable over our interval. But then Rolle's theorem also adds the last one, where we have to verify that f of a equals f of b. All right, so first of all, is it continuous and differentiable? Well, notice that this is a trigonometric function. It's cosine. We know what cosine looks like, right? And so since we know that it's a wave function like this, we know that yes, that is continuous. That has no holes or asymptotes in it. That's what would cause us to make it not continuous, as if we could say there's a hole or an asymptote there. Usually that comes up when we try to divide by 0 or something along those lines. And so yes, it is continuous, and it is also therefore differentiable, because you can see on that graph there that it is in fact differentiable at every single one of those points. Again, discontinuities tend to be the causes of it not being differentiable. Not the only things, but most of them. That now leaves us with just one thing left to check, and that is we need to figure out, does f of a equal f of b? So that means we need to figure out what is the value of f of 0, the first point of our interval, and the value of f of pi, the second point in our interval. And so I'm going to take each of those and plug them in. So I'm going to do cosine of 2 times 0 and figure out what that is. So 2 times 0, of course, is 0. So this is going to be cosine of 0 here. And cosine of 0, yes, you should know that from your unit circle. That's going to give us 1. All right, then f of pi, that means we're going to be doing cosine of 2 times pi, which of course then is 2 pi. Well, 2 pi is actually coterminal on our circle with 0, so it of course would have to have the same value of 1. So yes, so f of a does equal f of b. All right, so now that we've verified that it satisfies the three hypotheses, we now are going to find all the numbers c that satisfy the conclusion of Rolle's theorem. All right, so that means we need to figure out where the derivative of this function is equal to 0. That's the conclusion of Rolle's theorem that we are now going to be figuring out. So in order to do that, that means we must find the derivative of our function. So we're going to be figuring out what is f prime of x going to equal here. And so the derivative of cosine is negative sine. So it's going to be negative sine of 2x. But notice since it's not cosine of x, it's cosine of 2x. Yes, we do need to use the chain rule. So multiply that then by 2. Or if we wanted to clean that up a little bit, we could write it as negative 2 sine of 2x. All right, now that we have that, we now need to solve that for where it's all going to equal 0. Well, for our first step, we could divide both sides by the negative 2. That would certainly make things a lot simpler. So then we have sine of 2x just equal to 0 still, because 0 divided by negative 2 gave us 0. And now I need to get rid of the sine, so I need to figure out, okay, at what values does sine equal 0? And if we think about our unit circle, we know that sine equals 0 at 0 and at pi. So there's two different places where it could happen. We could have one where I would have it equal to 0. And again, the stuff that's in the inside is just staying on this side over here. Or we could have it where the 2x on the inside is equal to pi. And again, I only need to use those. I don't need to keep going around the circle and over again because our interval is only from 0 to pi here. And so if I now go and solve each of those, I find that x equals 0 and x equals pi over 2. All right, now looking at this, the question then that should be coming to mind is, do we include this? Because That's right at one of our endpoints in our interval, right? So can we actually include that endpoint as one of those points in one of our solutions? And if we look back at our notes that we took on Rolle's theorem, we would see this particular detail in the language where we're finding the value of C in the interval from A to B, not inclusive. So notice that those are parentheses there, not the square bracket. So it does not include A and B. So C cannot equal A or B. It has to be between them. Therefore, this x equals 0 is not a possible solution, but the x equals pi over 2 is. So that is our one solution in this particular problem, that x equals pi over 2.